Dear third prep, Assalamu alaikum wa rahmatullahi wa barakatuh. It's Mr. Ahmed Mahmoud with you today to introduce a new mathematics lesson. Today, inshallah, we have Algebra. It's Unit 1, Lesson 2. The lesson is called the relation and function mapping. Last time we talked about the Cartesian product and how can we represent this Cartesian product graphically and how can we write this Cartesian product. Today, inshallah, we are going to learn the meaning of the relation and function and how can we represent the relation and what is the difference between the relation and function and how can we represent them graphically, and we are going to solve many problems about this concept. It's a very important lesson for this year and for the next years in the first secondary and in the second secondary. Most of the algebra depend on the function, so it's a very important lesson to understand. Let's start the lesson. Before explaining the meaning of the relation, we need to remember the meaning of the Cartesian product and how can we write its element. Okay, first, if we have set X like this included 1 and 2 and another set Y included 2, 4 and 3. To find the Cartesian product X product Y, as I said before, we are going to distribute X among Y like this: 1 and 2 in order pair, 1 and 4, 1 and 3, and then 2 and 2, 2 and 4, and 2 and 3, and then we are going to close the set. Okay, as we see here, we have already took every element inside or distribute every element inside X among every element inside Y. We took all the elements, so we have here 2 times 3, 6 elements. We have already 6 elements. Okay, but in the relation we are going to take some elements from the Cartesian product. These elements depend on a rule. This rule comes in the questions, in every question in the relation, like this. Here, every order pair formed from 2 numbers. The 2 numbers, as I said before, the first number is X and the second number is Y. Or we can say that the first number is A and the second number is B. In the relation, we called the first A and the second B. Okay, now we have some examples for some relation to explain what the meaning of the relation. Okay, we have here some relations. The first relation, if A equal half B. This is the rule of the relation. By looking to every bracket inside this Cartesian product, we are going to search when A equal half B. In the first one, the first bracket, A is 1, B is 2. Here 1 equal half 2. Then 1 and 2 satisfy this relation. The second one, 1 and 4, 1 is not half of 4. Then this one doesn't satisfy the relation. Here 1 is not half 3. Then this one doesn't satisfy the relation. 2 is not half 2. So this one doesn't satisfy the relation. Here 2 equal half of 4. Then this one satisfy the relation. Then the first relation with us, we can say that this one satisfies the relation and this one satisfy the relation. So I'm going to take 1 and 2 and 2 and 4 in the relation. Finally 2 and 3 doesn't satisfy the relation. So the relation in the first relation included R is the name of the relation, set of 1 and 2 and 2 and 4 like this. Okay, and then we are going to close the set. Another relation, if A plus B equal 5. 1 plus 2 is not 5, so this one doesn't satisfy the relation. 1 plus 4 satisfies the relation. 1 plus 4 equal 5. 1 plus 3 doesn't satisfy the relation. 2 plus 2, 4 doesn't satisfy the relation. 2 plus 4, 6 doesn't satisfy the relation. 2 plus 3, 5, this one satisfy the relation. Then the relation included 1 and 4, 2 and 3. So I will write R equal set of 1 and 4, 2 and 3, and then I'm going to close the set. So we can say that the relation in the two examples is a set of some order pairs from the Cartesian product. When we say some order pairs, then we say that R is a part of the Cartesian product, or R is a subset of the Cartesian product, like this. Then R is a subset of the Cartesian product, and this is the definition of the relation. Then what's the meaning of the relation? The relation, in the relation, we took some elements from the Cartesian product according to the rule he gives me in the example. Okay, now we are going to explain the meaning of the function. Now I mentioned the meaning of the relation, okay, but before explaining the meaning of the function, I'm going to solve an example like the exam examples. Here we have example on the relation. Okay, this is the example. X equal 2 and 2, 3 and 4, y equal 8, 27 and 64, and R is a relation from x to y where a r b means a equals cubic root b. For each of a belongs to x, b belongs to y, write R and represented by an arrow diagram. Okay, now I'm going to explain every item in this example carefully. Here we have set x and set y. We have here two sets, and R is a relation. The relation is called R, as I said before, and the relation from x to y. What does it mean? The relation must include three items or three elements. The first item is the sets. The sets here are x and y. The second item is the direction. The direction here start from x, go to y. Sometimes the relation start from y to x, but here we have from x to y. This one called the direction of the relation. And ARB. What's the meaning of ARB? ARB is the abbreviation of A related to B. And as we said before, A is the element of x and B is the element of y. Yani every element inside x called A, every element inside y called B. And finally, and this is the first, the most important one, this is the rule of the relation. A equal cubic root B. This is the rule of the relation, as we said before. For each A belong to x, B belong to y, write R. This is the required and represented by arrow diagram. Okay, now I have explained every element inside the question. Let's solve the question. To solve this question, we start with the rule. The rule here, A equal cubic root B. Again, A equals cubic root B. It's better to start every time with B, not with A. So, to start with B, I need to cancel the cubic root. As we said in the second prep, to cancel the cubic root, then we reverse the operation. The opposite operation of the cubic root is power 3. Then I'm going to raise the two sides to the power 3 like this. A to the power of 3 equal A power of 3, and the cubic root B power of 3 equal B. Then the relation will be right like this. Now I'm going to reverse the operation. B go to the left side and A power 3 go to the right side like this. Okay, b equals a to the power of 3. Now I'm going, a, as I said, is the element of x. Then I will put 2 in place of a, and 3 in place of a, and 4 in place of a, like this. If a equal 2, at a equal 2, then b here equal what? B will equal, according to the relation, to the rule of the relation, 2 power of 3 equals 8. Then at a equal 2, b equals 8. At a equal 3, we will put in place of a 3, then it will be 3 power 3 equal 27. At a equals 4, then b equal 4 power of 3 equals 64. Here, if a equal any element of x, then b took another element from y, like this. Now I found the images or the elements of a and the elements of b. Now I'm going to write these elements inside a set which is called R, like this. R equal, now I'm going to put 2 and 8 inside inside an order pair, 2 and 8 together inside an order pair, and 3 and 27 inside order pair, like this, and 4 and 64 inside order pair, like this. And then I'm going to close the relation. Now the relation included 2 8, 3 27, 4 and 64. This is the 3 elements of the relation. Okay, now I need to represent this relation by an arrow diagram. Okay, in the arrow diagram, we put x inside rectangle like this and y inside rectangle like this. The elements of x are 2, 3, and 4. The elements of y, 8, 27, and 64. Now, I'm going to connect 2. Last time in the Cartesian product, we was connect 2 with all elements of y. 2 is 8, 2 is 27, 2 is 64. But now, I only connect 2 with 8, like this. And I'm going to connect 3. 3 only connected with 27. And 4 is only connected with 64. Of course, this connection depend on the relation and depend on the rule of the relation. Okay, 2 with 8, 3 with 27, 4 with 64. Now I explained the relationship between x and y, and how can we solve this one. This is a very important question. Now I'm going to explain what's the meaning of the function. Let's start explaining the function. Before explaining the function, I have 3 relation examples. I'm going to explain the 3 relations, and from the relation we are deduce what's the meaning of the function. Okay, the first example with us. This is an example. If we have a relation connected between x and y. If x included red, white, and black, and y included black, red, white, and yellow. Here in x we have the names of the colors. Here in y we have the colors itself. Okay, now the relation, to connect this relation, I will connect red with its color like this, and white with its color like this, and black with its color. Okay, here in this relation, as I said, this relation, every element from x has a mission. The mission of red to connect with its color. The mission of the white connect with its color. The mission of black to connect with its color. Suppose that every element is in x as much as a bottom. Okay, here explaining what I said, every element has only one mission. Of course, every element from x has only one mission. Okay, another example. If X included red, white, and black, Y included black color, red color, and yellow color. Here, red connect with red, white connect with nothing because we haven't white here, black connect with black. So here in this example, white hasn't any mission in the other side or hasn't any image in the other side. Written like this, an element hasn't any mission inside a Y. Here I mean the elements of X. Okay, another example, X and Y like this. X included the word color and the word letter and the word number. Y included black color and red color, number 4, and letter K. The word color was connect with the colors. The colors here are black and red, like this. The word letter connected with the letter. The letter is K. The word number connected with the number, which is 4. Now we have a bottom in X included 2 missions. Okay, now here an element has more than mission. Okay, before explaining which of them is a function and which of them is not a function, remember with me the calculator. The calculator included a buttons like this. When we press 1, appears 1 here. If I press 2, appears 2 here. If I pressed times, appears time here. If I, for example, need to multiply 2 times 3, the answer will appears here. Okay, then every bottom here included a function. Again, every bottom here included a function. So this bottoms are functions, or for every bottom here included a function. For example, if you need to change the function of any bottom, okay, you press shift. For example, here we have fraction. If I need to change the function, I will press shift fraction to give me mixed fraction. Okay, then I can't find any bottom here included 2 functions in the same times. Yani for example, if you press 9, it doesn't appear 9 and another number, it's only 9. Okay, so every bottom must have one function only. Okay, we have here 3 examples. In the first example, every element has one mission. In the second example, an element hasn't any mission. Okay, in the third one, an element has more than mission. Okay, in the same time. So the first one is a function because every element must has one mission only. The second one is not a function because an element hasn't any mission. The third one is not a function because an element has more than image. Okay, now it's clear that the function is a special case of the relation. If the relation between 2 sets, okay, included an elements of the first set in which every element has one mission only or one image only, then this one is a function. If an element hasn't image, then this one is not a function. If an element has more than image, then this is not a function. Okay, this is the meaning of the function. Okay, let's explain an example for the function. Now I suppose the function, okay, like a machine. In the function, here the input and here the output. Okay, and here the rule of the function. Okay, what is the input of the function? The input of the function is a set X, or the first set is the input of the function. Okay, Inside the machine, we have the rule of the function, and here we have the output of the function, which is the set y. Okay, then the function looks like a machine. We have input, we have output, and we have the function machine itself, which is the rule of the function. Now it's clear what the meaning of the function. The function is a relation, but in which every element from X or from the first set must have one mission only. Okay, let's solve an example for the function. In this example, if X equal 2, 3 and 4 and Y equal 6, 2, 3, 4, 5, 7 and 8, and R is a relation from X to Y, where A are B or me, which is mean A related to B. A equals half B. This is the rule of the relation. I will highlight this one. This is the rule. It's very important. Okay. And now A belong to X and B belong to Y. Write R and represent by arrow diagram. And is R a function or function from X to Y? Okay, now I will start with a rule. As I said before, it's better to start with B. So if A equal half B, that mean B equal double of A, B equal to A. Okay, first I will start with 2. At X equal 2, excuse me, here A, at A equal to, at A equal to, then B equal 2 times, this is by using the rule, B equal to A, 2 times 2 equals 4. I will put it inside order pair 2 and 4. Okay, at A equal 3, B equals 2 times 3 equals 6. At A equal 4, then B equals 2 times 4 equals 8. Okay, now I found all the elements. I will write them inside an order pair, inside the relation, like this. R equal set, open bracket, 2 and 4, 3 and 6, 4 and 8. Okay, here as we see, 2 connected with 4, then 2 has one mission. 3 connected with 6, then 3 has one mission. 4 connected with 8, therefore R is a function. R is a function because every element from X has one image from Y or has a mission, okay, inside Y. Okay, now I'm going to represent by an arrow diagram like this. Inside X, I'm going to write the elements of X, 2, 3 and 4. Inside Y, we have 6, 2, 3, 4, 5, 7 and 8. Now I'm going to connect 2 and 4, 3 and 6, 4 and 8. Don't forget, here the images are 6, 4 and 8. 6 is called the image of 3. 4 is called the image of 2. 8 is called the image of 4, and I will explain this one in the next one. In the last example, we had x and y. X had 2, 3, and 4. Y 3, 2, 6, 4, 8, and 5. 2 connected with 6 with 4. 3 connected with 6. 4 connected with 8. As I said before, this one represents a function because every element in x has one image in y. Again, every element in x has one image in y. Okay. So, in that case, the first set x has a name. This name is the domain of the function. Then, if we have a function, the first set called the domain of the function, and the second set called the codomain of the function. Okay, remember these names, it's very important. X is a domain and y is a codomain for the function. Okay, and the images 6, 4, and 8 called the range of the function. Again, we have three names. It's very, very important. The first set called the domain, the second set called the codomain, and the images or the answers of the question or the output called, this is the output of the function, is the range. Then the range is the output of the function. X is the input of the function and the range is the output of the function. We write the range like this inside a set 6, 4, and 8. It's very, very important. It's the input and this is the output of the function. Okay. Now, as I said before, 6 is what? 6 is the image of 3. And 4 is what? 4 is the image of 2. And 8 is what? 8 is the image of 4. Don't forget these names. 6 is the image of 3. 4 is the image of 2. 8 is the image of 4. Here 3 is the image of nothing. It hasn't number here. Okay, connection here. Then 3 is not an image. 2 is not an image. 5 and 7 are not images. Okay, don't forget, it's a very important remark. Here in example 2, x equal 1, 3, 4, and 5, y equal 1, 2, 3, 4, 5, and 6, and R is the relation from x to y where a plus b equal 7. This is the rule of the relation. For each a belong to x and b belong to y, and R is a relation represented by an arrow diagram and also by Cartesian diagram. Okay, now I'm going to write R. The rule here I'm going to send is a plus b equal 7. I'm going to send a to the other side. It will be b equal 7 minus a. Okay, if a equal 1, then b equal 7 minus 1, 6. If a equal 3 from here, then b equal 7 minus 3. Don't forget, this is the rule I'm using. b equal 7 minus 3 equal 4. If a equals 4, then b equals 7 minus 4 equals 3. If a equals 5, then b equal 7 minus 5 equals 2. Okay. Now I'm going to write R. R equal set of 1 and 6 and 3 and 4, 4 and 3, finally 5 and 2, and then I'm going to close this one. Okay, now R is what? R here is a function. It's function. Why? Because every element here, A appears 1, 3, 4 and 5. Every element from X appears only one time. Again, every element from X appears only one time, okay, in the relation. Then this one is a function. Now I'm going to represent by an arrow diagram, and here I'm going to represent by the Cartesian diagram. First, I'm going to write the elements of X, 1, 3, 4 and 5. The elements of Y, 1, 2, 3, 4, 5 and 6. 1 connected with 6, 3 connected with 4, 4 with 3, and finally 5 connected with 2. So every element from X has one image from Y. The Cartesian diagram, like this. Here X included 4 elements like this. I will write the elements of X, 1, 3, 4 and 5. And Y included 6 elements like this. Here I'm going to write 1, 2, 3, 4, 5 and 6. Okay, the first one, 1 and 6, then 1 and up with 6, I put 1 point. 3 and 4, 3 and go up to 4, 4 and 3, 4 and 3 here, and 5 and 2 here. It's only, yes, it's a function because every element from X, this is the first set X, 1 included one element, one image, 2 included one image, 4 included one image, 3 here included one image, 5 included one image. Then every element in X has one image in Y, so this one is a function. And here every element from X has one arrow to Y, then this one also is a function. Another example. In this example, X equals 0, 1, 4 and 7, and Y equal 1, 3, 5 and 6, as we see. And R is a relation from X to Y, where A or B means A plus B smaller than 8. Okay, for each A belong to X and B belong to Y. Write R and represent by arrow diagram and also by Cartesian diagram. Okay, I will write R directly. R here equal set of 0 and 1. 0 and 1, 0 plus 1 equal 1. It's smaller than 8. I will take it 0 and 1. Don't forget 0 is A, 1 is B. 0 and 3. 0 and 3, 0 plus 3 smaller than 8. 0 plus 5 smaller than 8. 0 plus 6 smaller than 8. Okay, now I'm going to take 1. 1 and 1 smaller than 8, 1 and 3 smaller than 8, 1 and 5 smaller than 8, 1 and 6 smaller than 8. Now I'm going to take 4, 4 and 1 smaller than 8, 4 and 3 smaller than 8. But 4 and 5 equal 9 greater than 8, and 4 and 6 greater than 8, so I will not write 4, 5, 4, 6. Now I'm going to write 7. 7 plus 1 is not smaller than 8. 7 plus 1 is 8. 7 plus 3 is 10, more than 8. 7 plus 5 is 12. 7 plus 6. So I will close the set. Then R here included 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 ordered pairs. Okay, now I'm going, this one of course not a function. R is not a function. But why? Because here 0 has 1, 2, 3, 4 images, 1 has 4 images, and so on. So the elements of X has more than image, because some elements from X have more than image in Y. Okay, now I'm going to represent by an arrow diagram. X included 0, 1, 4, and 7. Y included 0, 3, 5, and 6. 0 connected with 1, 0, 3, 0, 5, 0, 6. And 1, 1, 1, 3, 1, 5, 1, 6. Finally 4, 1, 4, 3. Okay, the arrow diagram, the Cartesian diagram. Here we have in X 0, 1, 4, and 7. Y 1, 3, 5, and 6. Okay, 0, 1, 3, 5, 6, 1, 1, 1, 3, 1, 5, 1, 6, 4, 1, 4, 3, and this is not a function, as I said last time. Okay, this is why this is not X. Okay, as we said before, here 0 has more than 4 images, and 1 has 4 images, and 4 has 2 images. Then this one is not a function at all. And also 7 hasn't images. We have here more than a reason to make this one is not a function. Let's solve the next one. X equals 0, 1, 2, and 3. Y equal 0, 1, 8, 4, and 9. And R is a relation from X to Y, where A power of 2 equals B. Where A belong to X and B belong to Y, write R and represent by arrow diagram. Okay, here the rule a power of 2 equal b, or b equal a to the power of 2. At a equal 0 from here, then b equal 0 power of 2 equals 1. At a equal 1, b equal 1 power of 2 equals 1. At a equal 2, b equal 2 power of 2, which is 4. At a equals 3, b equals 3 power of 2, which is 9. Okay, then I'm going to write R. R equals 0 and 0 power of 2 equals 0. 0 and 0, 1 and 1, 2 and 4, 3 and 9. Here 0 has one image, and 1 has one image, 2 has one image, 3 has one image. So this one is a function. Then R is a function because every element from X has one image from Y. This is the reason which make this one a function. The arrow diagram, X included 0, 1, 2 and 3. Y included 0, 1, 8, 4 and 9. 0, 0, 1, 1, 2, 4, 3 and 9. If I need to write the range, the range here included set of 0, 1, 4 and 9. 0, 1, 4 and 9. Don't forget, X is the domain and Y is the co-domain. Okay. In this example, R is a relation on X. What's the meaning on X? Relation on X means from X to X. That means the first set is X, the second set also X, which is 0, 1, 2 and half. X to X. Okay. And R, A or B means A is a multiplicative inverse of B. We remember the multiplicative inverse. The multiplicative inverse, we are going to change the fraction upside down. Where A belong to X and B belong to X also, write R and represent it by arrow diagram and show if R is a function or not. Okay. Here at X 0, okay, at X equals 0, 0, its multiplicative inverse 1 over 0, and it doesn't exist here because 1 over 0 is undefined. So 0 has no images. Okay, 1, its multiplicative inverse is 1. So I'm going to write R directly. R 1 and 1. 0 hasn't image. 1 and 1. 2 and its multiplicative inverse 1 over 2. 1 over 2 its multiplicative inverse 2 over 1. So 1 over 2 its multiplicative inverse is 2. Here 1 has image, 2 has image, half has image, 0 hasn't image. So I can say that R is not a function. R isn't a function because an element from the first set hasn't an image from the second set. Okay, the arrow diagram 0, 1, 2 and half, 0, 1, 2 and half. 0 has no images. 1 its multiplicative inverse is 1. 2 its multiplicative inverse half. Half its multiplicative inverse is 2. And I said this one is not a function. Another example, example 6. If x equal 6, 4, 2, 0, negative 2, negative 4, negative 6, okay, and R is a relation on x, then the relation on x, it's from x to x. Then the first set is x, the second set also is x. 6, 4, 2, 0, negative 2, negative 4, negative 6. Okay, now I need to represent by arrow diagram. The rule here is A is additive inverse of B, or write R and represent by arrow diagram and show with reason if R is a function or not, and mention its range. Okay, first I will write R. Six, its additive inverse is negative 6. Then 6 has image. 4, its multiplicative inverse is negative 4. 2, its multiplicative inverse is negative 2. 0, its multiplicative inverse is 0. Negative 2, its multiplicative inverse is positive 2. Negative 4, its multiplicative inverse is positive 4. Finally, negative 6, its multiplicative inverse is positive 6. Okay, then I can say that therefore R is a function because every element from the first set has one image from the second set. Okay, and here I can write the range equal -6, -4, -2, 0, 2, 4, and 6. Okay, and by represented by arrow diagram like this. Six, its multiplicative inverse is -6. 4, its multiplicative inverse -4, excuse me. 4, its multiplicative inverse is -4. 2, its multiplicative inverse is -2. And 0, its multiplicative inverse 0. -2, its multiplicative inverse is +2. -4, its multiplicative inverse is +4. 6, its -6, its multiplicative inverse is +6. Okay, this is the representation of this one, and I said this one is a function. The next example. In this example, if f is a function from x to y, then x is called. If this one is a function, then x is the domain and y is the codomain. X here is the domain. If f is a function from x to y, then y is called. Here x is the domain and y is the codomain. R is a function which equal this one, then the range equal 3, 5, and 7. 5 and 7. In the opposite figure, okay, this one is a function, then the range. Here, okay, I can write it by another way to be easy. X to x, here we have A, B, and C. A, B, and C. A go to A, and B go to A, and C go to A also. So the range here is A, is set A. And this is the end of the lesson. I hope it was helpful for you. See you in the next video inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh. Mr. Ahmed Mahmoud was with you.